All right. So looking at this picture, I know it's kind of small for some of you in the back, but we do have a hole right here. So we do have an undefined point at x equals 2. We also have that vertical asymptote running here, as I call that, so my x-axis is running through at x equals 1. So it is also undefined at x equals 1. That would be all undefined places. Different how they're undefined vertical asymptote versus the hole, but those are places that it is undefined. So then looking at our vertical asymptotes, one thing I did notice as I walked around the room on your notes on that last part, and I did address it a little bit, but making sure that we understand every asymptote, whether it's vertical, horizontal, or today's slant, has to be the equation of a line, because they are lines. And so when we are answering a vertical asymptote, vertical lines are of the format equals. So a lot of us had like a number where it was running on our note sheet yesterday. As I came around and checked, you need to add the x equals in front of the vertical asymptote and a y equals depending on horizontal asymptote. We'll keep cleaning that up as we go. But it's running right here at x equals positive 1. Right, the equation of the horizontal asymptote a little bit not as obvious because it's not drawn in this particular picture. So hopefully you can see where that's flatlining on your left and right, and that is at 0. And we'll get horizontal. Anything asymptote has your equation. Horizontal line then today also slant will be y equals. Horizontal lines are just y equals a number, and ours is flatlining here at y equals 0. Any questions on that part of it? Okay. So we are doing day 2. We kind of skipped over the domain part within our notes yesterday, so we'll make sure that we kind of address that today. You already know how to find the domain of rational expressions because we did it before we even started our notes yesterday. But looking at it in terms of each of our functions today, finding our vertical horizontal asymptotes still, but also adding to that our slant asymptotes so that we can graph all rational functions. So recapping what we learned yesterday, you're going to see this instead of that like step-by-step guided sheet. We start always for looking for a hole in our graph. And so this, remember, is what crosses off. We start here. But it's always an ordered pair. Some of us are forgetting the ordered pair part of it. But in that ordered pair, it is what we cross off. Set equal to 0. And then what we got plugged into leftovers. So the function after we have simplified it, right? After we have checked off that it either has a hole, we take care of finding it, or it doesn't have one, move on, right? We went to our vertical asymptotes. Our vertical asymptotes were our numerator. Anything in our denominator. Anything in our denominator set equal to 0 must be x equals. Our vertical asymptotes have to be written as an x equals because they are vertical lines. Then we move to horizontal and slant. We did not see this yesterday, okay, so that's not a recap for us. Horizontal can come in one of 2 ways. In a little over big would be a y equals 0 horizontal asymptote, y equals. Or a same over same. And if that happened, it would be y equals the ratio of the leading coefficients, the number in front of our biggest x. What's the biggest x? Today we will find out what this is all about. Our slant asymptote that comes from any time we have a big over little. So we'll learn how to find that today. Then we move down to our, and remember, these are mutually exclusive. You can't have both, right? Because it can't be in more than one category, little over big, big over little, or same. So you can only have one or the other of those things. Once you figure out which one it is, you automatically the other one is just not exist for any or none, right? X-intercept is our numerator. Anything in our numerator set equal to 0. things we talked about with our x-intercepts, you can have multiple x-intercepts. You can only have one y-intercept, and that's what we get when we plug in 0. Now, I will tell you, ultimately, the order that you go through finding all those things does not matter as long as you find a hole in your graph first. If you do not check for a hole in your graph, your vertical asymptotes and x-intercepts could absolutely be incorrect. It will not impact y-intercept or your slant or horizontal. But if you do not find the hole first, it would probably give you the, if there was a hole, it would give you the wrong x-intercepts in the question. Okay, so none of this changes today, other than we're now going to learn how to find this. Okay, so slant asymptotes. Slant asymptotes is that third category of categorizing our fraction as little over big, big over little, or same. It's the big over little. So you'll notice in the book definition of it, the graph of rational function has a slant asymptote if the degree of the numerator is 1 more than the degree of the denominator. Big over little. Okay. So how do we find it? We find it by dividing the numerator by the denominator. You have two methods for dividing. You can pick the method you like better. So we have long division and we have synthetic division. I will always show synthetic division, but if you want to show long division, that is up to you. It's your preference. Okay. So we will divide it. You will ignore the remainder. Okay, so let's use this. Now, please look at your note sheet. I have altered the question after I printed the note sheet. So I believe you have a different sign on your problem that I have on mine. Please update it to what I have up here. 2x squared minus 5x minus 7. Over x minus 2. Okay, so first of all, we would look to see if this simplifies. This is actually factorable, I believe. Let's see here. We get 2x and x, and I need a -5 here. X is positive 2x. Okay, that does give me. That is not. It does not need to be factorable. However, let's see if I make that. Let's make this a negative. That way it is factorable. For our next step, we'll just make that middle term a negative 3x. Okay, now let's double check that that is correct here. We should be good now. Okay, regardless, does it simplify? No, it does not simplify. So in that case, yes, it is factorable. We will eventually look at it in the practice form when we go to graph it. But to find the slant asymptote, you will want to go back to the unfactored form so that we can use synthetic division or long division, your choice. So we would look at synthetic division, which would be 2. I altered it to now -3, -7. Okay. We are dividing by x minus 2, which means that we positive 2. We don't harm the factor to the 0, right? So putting a 2 out there, let's see, 2 times 2 is 4, minus 3 would be 1, 2 times 1 would be 2, and plus -7 would be -5. You will always ignore the remainder. So at this point, once we have done the division, you ignore whatever this is. It makes no difference. Okay, and to find our slant asymptote, it will be the equation we get when we turn that back into the polynomial. Make sure that you write it as an equation. So it will be y equals and then 2x plus 1. Before we move on, just a quick reminder on what that means as far as a line. Let's go back to our basics of how do we graph something like this. Remember that this is y equals mx plus b, but that's your y-intercept, and that's your slope, which is rise over run. So if I were to go graph this, we start by putting that dot, the y-intercept, on our y-axis. So for the equation specifically that we got, that has a y-intercept of +1, I would put a dot of 1. Okay? If you just graph this line, I would make this look like a fraction, and that's up 2 over 1. So I go up 2 over 1, or we can always go backwards down 2 back 1, right? Now, here's the deal. It's an asymptote. So you need to be cautious as you're graphing this, because if I put dots there, sometimes people confuse that with dots for like our actual graph. We're just helping ourselves see where that is. And so a lot of times, instead of putting a dot there, I would put a dash there, and a dash here, and a dash here, because eventually I'm going to put dashes through all of those. Because asymptotes are just going to be dotted lines on picture, just invisible barriers that we're making visible with the dotted line. Okay? So just be careful if you put a dot there as you're graphing your asymptote, that you don't think that it's a dot that you're supposed to be graphing through for your actual graph of your rational function. Any questions on the slant asymptote? Make it an equation by starting with that y equal. All of our asymptotes need to be a x equals or a y equals equation. Okay, so let's see this in action. I'm going to change this to what we just did, to a negative 3x minus 7. Yes, I will want to look at it in the factored form, which we just had on the last page. Okay. Again, the reasons that I want to look at it in the factored form, again, to make sure that I don't have a hole. We do not have a hole in our graph. And that's exactly where we start all of this. We don't have a hole in our graph. So then I can move on to my vertical asymptote, just like we did yesterday. Nothing changes at this point. So I move on to my vertical asymptote. My vertical asymptote is anything in my denominator set equal to 0. It has to be written as the equation of a line. So x equals 2. So graph that. What is new today is our slant asymptote. So in the next step, we would still say, is it a little over big over little or same? Reminder, if it comes to us in the factored form, we do have to remember to consider what the first term would have been, which would be a 2x squared, not like an x to the first one factored, right? Just like if I had asked you the ones, we would put those first terms back together. So it's a big over little, an x squared over an x to the first. That means slant. If it is a slant, we automatically know that we do not have a horizontal asymptote. So remember, slant, we are going to divide, just like we did on this page. There's our slant asymptote. Y equals 2x plus 1. Divide, ignore, remainder. Okay. So because I'm actually graphing it here, when I go to graph this, I am going to put it all as dotted lines, not with the dots in there. So it crosses my x-axis up at 1, has a slope of 2, so up 2 over 1, up 2 over 1, 2 over 1. Like that. All right, so there's all of our asymptotes. Then we move on to the graph part of it, the x-intercepts, y-intercepts, and any additional points that we need. So x-intercepts was in our numerator. Ooh, we have two things on our numerator, 2x minus 7 and x plus 2. So I get 2 x-intercepts, add 7 divided by 2. Okay, here you do not have to have an x, but I always do. But those can just, intercepts can just be plain numbers, just so you know. You can also make them order pairs. I make them x equals or y equals, which is fine. But 7/2 is 3.5. So I have it done at 3.5 on my x-axis, and I have it done at -2 on my x-axis. Remember, x-intercepts, we have multiples. Y-intercept, plug in 0. I would go back to the unfactored form. Gives me a -7 over a -2. Those negatives are cancel. 7/2 is again 3.5. So on my x-axis, I've got 3.5. Any questions? Okay. So when we have a slant asymptote, our graph will look one of two ways. But again, we break our graph by the x and the y, by the vertical asymptote. We had one vertical asymptote. So if I look to the right of that, do I have any points to the right of my vertical? Yes, we have one. Just like we did yesterday, I continue to just follow my asymptotes. So I follow my vertical asymptote. I hit the point that I have here, and then I would come up and follow my slant asymptote. Okay. We do the same thing. Oh. Do this. Oh. What? Let's get rid of that. Try that again. So on the left-hand side of my vertical asymptote, which would be here, again, I have two dots. We follow asymptotes. So I'm going to follow my asymptote, go through those two dots until I get to my vertical asymptote, and then I slide along my vertical asymptote. Your graph will kind of look one of two ways. That is one of those options where it kind of looks like elongated corners to the right and left of your vertical asymptote. The other one will kind of look like pinched angled parabolas, because it can either be here or it could have filled in here. But keep in mind, guys, these are functions, right? And a function means that it will pass my vertical line test. So had I drawn this in and then I had a second piece down here, you see that this would fail my vertical line test because I graph here and here. And so that's a good indication. You put a piece of the graph in the wrong little quadrant that you're seeing show up there, is that we shouldn't always still pass our vertical line test. So those two pieces will not have worked. These will work with each other as far as being a function. All right, I think I have two more examples for us today. Okay, as always, we start with the factoring considered and look for a whole line graph. Start there. Do we have a whole line graph? Yes. All right. Yes, I will factor to look for that hole in the graph, but because of the big over little, we will want to go back to this for the divide part of it in order to find our slant asymptote. Okay, so we have now decided big over little. Big over little leads me to slant, which means we do not have a horizontal asymptote. So finding my slant asymptote, I need to divide. And if you prefer long division, you are welcome to do long division at this point, but do the same thing, ignore your remainder. The nicer part about long division is that it puts the x's in there for you. You wouldn't have to remember to go back and make it into x's. Okay. So I'm setting up my synthetic division. I prefer synthetic division. Setting up my synthetic division here. 3 times 1 is 3. Plus negative 4 is negative 1. 3 times negative 1 is negative 3. And it doesn't matter at this point because we ignore that number. Transition this into my equation up here. It needs to be a y equals. I'm going to take these and put them into the equation y equals 1x minus 1 or y equals x minus 1. And then it's just that we need to remember how to graph something like this. Okay, so y-intercept of negative 1, slope of positive 1. So I'm going to cross my y-axis at negative 1 and go up 1 over 1. Along the way across my graph. Oh, I forgot to do the vertical asymptote in there. So we need to put our vertical asymptote in there. What is in our denominator? So you put 0. Should have a vertical asymptote over out. Okay. We're pause there. How are we doing on our plant asymptote? Okay, figure it out. Okay, then the intercept cannot change. X-intercept, what's in our numerator, is equal to 0. Y-intercept, what is in, set 0 in. A lot of times with a slant, you will end up with 2 x-intercepts. Happens a lot. Not a rule. So you'll see it happen a lot. We do have, again, 2 things in our numerator. So x minus 5 equals to 0 and x plus 1 equals to 0 gives us 2 x-intercepts of 5 and negative 1. Notice, you are welcome to write your x-intercept as this number. If you're worried about remembering, you can always write everything as like an x equals or a y equals, and then you won't ever be wrong on your answer. Okay, but intercepts are obvious what it is. So you can just put a number there, positive 5 and negative 1. And our y-intercept plugging in 0 again. I'm going to go back to the unfactored form because it's easier for me to plug in 0 there. I get a negative 5 over a negative or positive 5 thirds or positive 1 and 2 thirds. Okay. Again, this is the slant one starts to mess with our heads a little bit, but use your vertical asymptote. You have a right side and you have a left side, so you should have a piece of graph to the right of your vertical asymptote. You should have a piece of graph to the left of your vertical asymptote, and that is it. Right, here's the slope. To the right of this line and to the left of this line. I should have 1 piece of graph to the right of that. I should have 1 piece of graph to the left of that. This point again would be enough. If I wanted to find additional points, we can plug in other points if we want to, like plugging in 4, just to make sure I get the right area here, but I have enough. Slide along my axis, go through that point, slide along my axis. Same thing over here, slide along my axis, go through those 2 points. Slide along my asymptote. So it kind of looks like those corners that we had yesterday, but they just got stretched out wider. Okay. Any questions for me? All right, let's look at our last one. This one I put on here because you see this type a lot. Oh no, just kidding. We do not see this type a lot. This is a special case. So initially, I look at this problem and think, oh, change it to this. Thank you. We did some updating after. Clearly, so much mistakes. All right. So they're saying, oh, special case. You need to see it because it'll happen. Obviously, a special case does not happen often. So it initially looks like a big over little, just like we've been looking at, right? It's the next third over next to the first. So I would anticipate a slant asymptote. However, when we go to factor correctly, is there a hole in this graph? Yes. So I cross that off. I know there's a hole, and what I just crossed off was an x minus 2. So I set that equal to 0 to find my x value of the hole, which is 2. But here's what the special case is. When I look at what's left over, we have an x plus 2 in the top and nothing in the bottom, which is a 1. Which it's in the denominator, I don't have to write a 1. And notice what's left over is not a fraction anymore. Yes? We have not seen that happen, and you don't see it happen often. But when you have a whole and the leftovers are a linear equation, okay? Whole, this is why it's a special case, because there's a whole and the leftovers are a linear equation. So just a line, no fraction left. What it ends up being is just a line with a hole in it. That's all it is. Okay? So this ends up being a line with a hole. Although it looks like the irrational expression to begin with, it is not going to look like any of the irrational graphs. It is just a line with a hole in it. Okay, now walking through the rest of this problem would lead us to that. So watch what happens here. First of all, to find the second half of the hole, I plug in what I got into the leftovers. So I plug 2 into x plus 2. And I go draw a hole at 2, 4. My next thing would be to set what is left in my denominator equal to 0 to get my vertical asymptote. So do I have anything left in my denominator? No. So you actually don't have a vertical asymptote. We did mention once that didn't have to be a vertical asymptote. We don't see that often in a special case. Okay, so then this is where it starts getting weird. Horizontal asymptote versus slant asymptote, little over big, big over little, are saying we would say slant. But because of the special case, there is neither of these. We do not have a horizontal or a slant asymptote because what's left over is just a line. Not a fraction anymore at all. Your x-intercept comes from the same thing. Remember, this is technically the numerator, right? So our numerator set equal to 0 would give us our x-intercept. It's going to hit our x-axis at -2, which you wouldn't necessarily have had to find if we just graphed the y equals mx plus b that is there, okay? Our y-intercept, again, if you just follow your rules, you will find it, but it's also y equals mx plus b. It is 2. But if I plug in 0, I still get the same answer of 2. And then my y-axis at 2. And then I need to understand again, it is just a line with a hole in it. It's a line with a slope of 1. I went through my x-axis at 2. I just need an open dot and 2 comma 4. All right, so there's your special case. Doesn't happen often. Happens enough times after this that we needed to talk about it once. Okay. Because I switched up the example here, I do want to just show you one other thing. Is there is one other option for how slant asymptote graph can look. We have seen two with kind of an elongated corner on the outside. The other option is kind of a pinched parabola here and here. So those would be the two shapes I would expect, and they do not mix and match. So you would not have a pinched parabola here and then an elongated corner here. So you either have kind of two pinched parabolas or two like stretched out corners. They don't go together. Like they don't cross one or the other while you're in. Okay. Any questions for me? All right. You guys have a worksheet today. I will read this one up here. You will see your special case show up on your worksheet today, so please make sure you go back to that part of your notes when you run into that one.